question ones are designed equally. So every now and then you'll find something that starts with the need for the quadratic formula as indicated by those keywords, 2 decimal places. So no need to attempt factorization over there. Let's just get going. So we know from our quadratic formula that x is equal to minus b plus minus the square root of b squared minus 4ac over 2a. So that's a minus 5 is equal to b, and then negative 1, that's our c value. Might as well do this in blue. So that's minus 5 plus minus square root of minus 5 whole squared minus 4. What's our a value? Well, 3, and our c value is negative 1. And we have 2 multiplied by 3 as our denominator. And doing this correctly with the modern calculator, we shall have x being equal to 1,85 or x equal to negative 0,18. Well, that's a better one. Good. So that shouldn't prove too much of an issue. In 1.1.2, well, we have x squared minus 6x plus 8 equal to 0. And if I have a look at that, because it's positive over here, we know both our factors are going to be have a negative sign in the middle, and those would be minus 2 and minus 4. There we go. Therefore x is equal to 2 or x is equal to 4 as dictated by the zero product rule. Well, to continue we need more space, so let's get rid of that. And remember, always feel free to pause the video at any time and use this as a time to exercise. Well, here we have a quadratic inequality. Let's just rearrange everything by dividing the entire equation by a negative 2. Well, we'll have, well, minus 2x plus x squared being greater than 0 because we divided by a negative, and rearranging that just makes more sense. And the factorization obviously is going to give us x multiplied by x minus 2 in brackets. Well, from there it's just a case of our critical values again. So we have x being equal to 0 or x being equal to 2. So there we have our smiley face parabola again with our values properly placed, smallest on the left, largest on the right. What are we looking for? Greater than, which is on top over there again. It's the right hand side, that's the left hand side over there. So that's where the shadows go, which means we are looking for x values less than 0 or x values greater than 0. So remember, this is only an indication of top or bottom, above the x-axis or below. Where the shadows fall dictates the solution. And I made a writing error over here, so let me fix that. That should be a 2. That's where that value came from, over there. Radio. Moving right along. Now we have something a bit more exponential in nature. So that's 2 to the power 3x plus 1 plus 2 to the power 3x being equal to 12. Or we can reverse our first exponential law by rewriting this as 2 to the power 3x multiplied by 2 to the power 1, of course. We have 2 to the power 3x, so equal to 12. Let's just see where this goes first. Well, as we can see over here, we have a common factor of 2 to the power 3x, and that is what we are going to exploit in this case. So we'll have 2 to the power 3x, no brackets. Well, if we're factorizing it out of there, what's left is a 2, and anything divided by itself is equal to 1, because that is what factorization is. It's just basic division, but for algebra. Well, that's all equal to 12. If I have a look there, that's equal to 3, which means we can divide both sides by 3, and we'll end up with 2 to the power 3x, because that's equal to 1, and 12 divided by 3 is equal to 4, which means we can rewrite this as 2 to the power 3x being equal to 2 to the power 2. Now we have the same basis, and therefore we can just equate the exponents, which means x is equal to 2 divided by 3, and that is good enough to get us to what the board wants more. Again, every question once set should contain good old-fashioned principal root equation. So we'll have square root of x minus 1 plus 3 being equal to x minus 4. And I do say principal root because as a general rule we're looking for the positive root. Remember, the square root of anything, let's just take 4 as a positive 2 as a square root, and negative 2, because negative 2 times negative 2 is also equal to 4, but in this case we're just looking for the principal root. From there, normal equation mechanics to apply, because we have the square root of x minus 1, we'll just subtract 3 from both sides to get a 0 over there, and it's x minus 4 minus 3 is just minus 7. Of course, to get rid of a square root, we just square both sides, so that'll give us x minus 1 as we want, and of course over here we'll have x squared, x multiplied by negative 7 is negative 7 times 2 is minus 14x, and negative 7 squared of course is plus 49. Right, let's transpose values that we need transposed, so plus 1 on both sides, and of course minus x on both sides. Let's see what that results in. Well, we wanted a 0 on this side, and here we'll have x squared minus 14 minus 1 gives us minus 15x, and 49 plus 1 is none other than 50. From there we can factorize or use the formula, whichever is simpler for thee, and of course we'll have x minus 10, x minus 5, thusly x is equal to 10, or x is equal to 5. Right, that's one part done. Then for the final bit, let's test these values. Well, the square root of 10 minus 1 is going to give us 9. So if we test the value 10 first, we'll get 9 over there, and the square root of 9 is equal to 3. Well, 10 minus 7 is equal to 3. Remember, I'm ignoring the green bits that I squared. Just using this for testing. That means that's fine. Then as far as 5 is concerned, 5 minus 1 gives us 4, and the square root of 4 is equal to 2, and then 5 minus 7 gives us negative 2. Well, those aren't equal, which means this is an invalid value, and that ends that.